previous class you have just learned how to locate, how to represent the number line, we call it. And there we were representing integers 0, 1, 2, 3, 4, and on the left side -1, -2, -3, like that. Okay.
Yes, ma'am.
So here we will see how to locate this irrational number. Irrational means non-terminating, non-repeating, right?
Yes.
Okay, non-terminating means it will not stop and it will not follow any particular pattern. It will not stop also. Okay, not stop, not follow pattern. So yeah, let's locate this irrational number on the.
Okay, ma'am.
First thing is, we won't be able exactly what is the value of root 2, we don't know. Okay, so exactly how we will be able to locate it exactly, accurately, how is that even possible to locate it? So there is a trick which we will use to locate. Okay, exactly, it is not possible. This is regular class. This is regular class, yeah, for our
Okay.
this is 9M1 and Tejas, you are in 9M2. We have included all the students over here from M2 also, so that since we in this batch we are done with all the chapters.
Ma'am, can you
Okay?
say again?
This is 9th M1 batch and you are in 9th M2 batch.
Okay.
Okay, just like section 1, section 2.
Okay.
So in this particular batch we have done with all the chapters till triangle. Now exam is knocking the door, so we have started the revision of each and every chapter, so that if anyone is struggling with any concept they can ask, or I can also introduce the new upgraded version of question which you can get in your exam.
Okay, ma'am.
Okay, which was not possible while explaining the concept. There we were having in the back of the mind it was going on that we have to cover the syllabus. So we are done with covering the syllabus. Now we can discuss all those questions which I wanted to discuss.
Okay, ma'am.
So root 2 we have to represent accurately. What is the value of root 2 we don't know. Okay, so if we will try thinking about that, like where exactly we can locate root 2 accurately, that is not possible. There is a trick which will help us, and the trick is to use the Pythagoras theorem. Okay, in Pythagoras theorem we already know that. Yes, everyone supposed to turn on their video, the camera. Yes, please, in every class I don't have to remind you. So we will take the help of Pythagoras theorem, which says that hypotenuse square is equals to perpendicular square, base square, whatever. So it says that AC square is equals to AB square plus BC square, right?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, what we are thinking that anyway, if we will take the help of this right angle triangle, and if we will be able to maintain the base as a 1 and the height as a 1. Now here I want to add one more thing. When I was taking the class 10 student, one of the students said that if I have drawn the triangle like that, just a second. Just a second. Let me show you first. Yeah, if I have drawn the triangle like this, we have dropped the perpendicular from this. Now, like regarding the area of the triangle, You are also aware with this area of the triangle concept. What is the
Yes, ma'am.
formula for area of the triangle?
One, 1/2 B to H.
Perfect. Shad. Can you tell me which side is the base over here and which side is the height over
B is height.
1B is height.
Let me name it properly. A, B, C. Tell me
Ma'am,
which.
BC is BDC is height.
Which one is the height?
BDC.
BTC. Height
Ma'am,
means a
BD.
length.
Ma'am, BD is height.
Just a second. Yeah, I was telling you that which one is the base and which one is the height. Height means a perpendicular. A perpendicular. Okay, height is perpendicular. So BD is the height over here. BD, BD is the height over here. And the other thing is what is the base over here? What is the base over here? BD is the height. Height means the perpendicular. The length of this perpendicular, that's called height. And the base is the base on which you are dropping the height. Okay, you are drawing the perpendicular on whatever side, that side is the base. This BC is not the base. This BC is not the base. On BC we don't have perpendicular. The perpendicular is on AC. So AC is the base over here. AC is the base. Till now we have shown you triangle like this, and that's why you are used to say that the horizontal side is the base, but it's not true. It's not true. You are dropping the perpendicular on whatever side, that is the base, and the perpendicular is the height. Okay, so is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, so we were
Ma'am, can
discussing
you
how.
show that again?
Yeah, sure, I can show this one here. AC on which we have dropped the perpendicular, that is the base, and the length of the perpendicular, that is the height. One more thing I can show you over here, which you will get to know in class 10, but just it's a very basic concept, that's why I'm showing you over here. Just a second. Now if you think that whenever we are dropping a height, we can drop from any of the vertex of this triangle PQR. It is not true. Okay, when we are dropping a height, it will lie in the triangle. That is not true. From the vertex P, if you will drop a height, a perpendicular, it will be like this, right? a 90
Yes,
degree you
ma'am.
will drop, it
Yes,
will
ma'am.
look like this, a rough sketch such just I'm showing you, it will look like this. Okay, if we will drop a 90 degree from r, a 90 degree from r, can you see how the height looks like? So for finding the area of the triangle, will this height will be considered which is lying completely outside the triangle? Oh yeah, yes, this is the height over here. Okay, and this height will be considered, this height will be considered for finding the area of this triangle only, pq1.
Okay, ma'am.
Okay, so height can lie inside and it can also lie outside, that is completely okay. We just have to, if you are not getting how will be getting the height, this, let's say this is p over here, not pp is already n over here. Okay, rn over here. So if you are thinking that what length you will be taking, so that means you just have to dot dot dot, you have to extend your base. Okay, you have to just extend your base. Now 1 by 2, still base into height will be the formula for area. Now here height is pn and here base is just pq, just pq, not the extended one. Extended one is giving us a direction that on this space there is a height. Okay, clear?
Yes, ma'am.
Now we were discussing
Yes,
this
ma'am.
part, how to locate this square root 2, and I said to you, if we don't know the value exactly for square root 2 and our computer, our calculator that is not capable of giving the exact value of root 2, then how is that even possible to locate it accurately exactly? So yes, Pythagoras theorem we will be able to use. Okay, what we will do over here, we will draw a triangle ABC where we will maintain the base and the height as 1 and 1. Then hypotenuse will be, tell me, AC square, the hypotenuse will be. If AB is 1 and BC is 1, then AC will be what?
under root 2.
Under root 2. Perfect. Okay. If AB is 1, BC is 1, AC will be root 2. Root 2. Okay. So this is how, this is giving us an idea that anyway, if we will draw a triangle over here where we will be, where we have to maintain the height as a 1 and the base as a 1, then automatically the hypotenuse will come out as a root 2. We don't have to think about the decimal number, what exactly is the value of root 2, it will lie in between which number and which number. We don't have to think about that. Okay, because that is not going to help us. What we will do, we will try making a right angle triangle on this number line. On this number line, we will draw, we will try making a right angle triangle. We will try maintaining the base as a 1 centimeter 1 unit and the height as a 1 unit. Automatically the hypotenuse will come out as a root 2. Getting it? Okay,
Yes,
and
ma'am.
Yes,
we
ma'am.
will take the measurement in
Yes,
our
ma'am.
compass that this much is root 2, this much is root 2, this much is root 2, this much is root 2. We will be taking the measurement in our compass and then we can mark it in our number line that this is the length, that is root 2. Okay, exactly value we don't know, but the length, this length is exactly root 2, this length is exactly root 2.
Yes, ma'am.
Okay, so let's do it. What we will do, from 0 to 1, we will be maintaining, we want to maintain the base as a 1 unit, so best to take from 0 to 1. Best way is to take from 0 to 1, 1 unit as a base, 1 centimeter as a base. Okay, 1 centimeter as a base we are maintaining. Then here we will drop a perpendicular. You can, if in your school the instruction is clear that you can use protractor, then you are allowed to use protractor. If the instruction is there that no, protractor not allowed, you have to use compass only, then please use compass. So this completely depends upon the instruction, okay, as given by your teachers. Okay, So here we will be dropping a perpendicular. I will be showing you how to drop a perpendicular with the help of the compass. I'll be showing you, don't worry. With the help of protractor, it is simple. Okay, you just have to place your protractor at this point. Let's say this is O, this is A. At A you have to place, okay, and then 90-degree you have to draw. Then you have to take your compass and make an arc of 1 centimeter, 1 centimeter, and then join this O with this B. This OB is root 2. Now I am going to show you how you are going to use protractor, how you are going to use compass over here. One by one I will be showing you. But tell me first whether this method is clear or not.
Yes, ma'am.
Okay. So if you are supposed to use protractor, then number line 0, 1. At 1 you can mark this is point A, and at point A keep your you need to keep your protractor. Okay, and here of course 90-degree will be written over there, yes or no? Okay, so
Yes.
just make a point over there, remove the protractor, and then just make a big line. But we don't need this big line, we just need 1 centimeter. Okay, so with the help of your scale you can in your compass you can mark 1 centimeter, or with the you can place your scale over here and you can just mark this much is 1 centimeter, that is point B, and from B to O you can join, and that is exactly root 2 unit. Getting it? Now if
Yes.
you are supposed to
Yes, ma'am.
use
Getting it.
anyway, okay, anyway, if the instruction is clear that no, you are supposed to use compass only, then let me help you with that also. 90-degree, how you will be making at this point A, you will make an arc like this of any measurement. Just try taking it like any measurement. Okay, you take it any measurement, more than half, you can take the measurement, and then one by keeping, first make an arc like this, then just keep the needle of the compass at a point, let's say this is M, so keep the needle of the compass at a point M, make an arc, then you will be getting 1 point over here, let's say this is N. Now keep the needle of the compass at a point N. You must have learned this method. Okay, so this much is 60-degree and this is also 60-degree. That means 120-degree we ended up getting, but we don't need 120-degree. We need 90-degree. We need 90-degree. So there is a way to do half of any angle. There is a way to do half of any angle. What you can do, you can place the needle at a point N. You can make an arc opposite. Then place the needle at a point P and then cut it, and that is the half of this 60-degree. 60 already we were having, I'm talking about this part. 60 already we were having, and we did the half also, this much is 30, and we will be joining like this, and we got 60 plus 30, that is 90-degree. We ended up dotting over here. However, we don't need this much huge big line. We just need 1 unit over here. So again, you have to take the help of compass. You have to measure 1 centimeter with the help of the scale. You can mark it like this, and then you have to join it like this. Is it crystal clear to all of you how to locate this
Yes.
irrational number on the number line?
Yes, ma'am.
Tejas,
Yes, ma'am.
okay, let's continue. Is it clear, Tejas?
Yes, ma'am.
Okay. Now the question is root 2 is okay, but how will be locating root 3? Who will say? Anyone from here? Who will say how to locate root 3? Who will say
Ma'am, root 2 plus 1.
root 2 plus 1 is root 3?
Ma'am, if we put the Pythagoras theorem,
Pythagoras
root 2
theorem.
square plus 1 square.
Perfect, perfect. Yes, exactly. If again we can take the help of Pythagoras theorem at this time, what we will do, we will take a triangle, a right angle triangle we will try making in such a way that one of the side is root 2 and another side is only 1. Okay, one of the side is root 2 and another side is only 1. Then if you will be using the Pythagoras theorem, that is hypotenuse square is equals to base square plus height square. If you will be using Pythagoras theorem, you will realize that yeah, it is coming out as a root 3. Check it.
Yes, ma'am.
Okay, PR is root 3. So by maintaining a triangle in such a way that one of the sides, see, it is not mandatory that you are going to keep this base as a root 2 and height as a 1. You can change it. You can keep base as a 1 and height as a 2, root 2, whatever is convenient to you. One of the side as a root 2, one of the side as a 1. But we try keeping base as a root 2. Why? Because from here, after locating root 2, see, this much is root 2. This
Yes, ma'am.
this OB is root 2. This red color line, this much is root 2. What we will do, we will take the measurement in our compass that, okay, this much is root 2, that we will make an arc on the number line like this. That from O to till this point, this is the location of root 2. So for drawing, for constructing, for locating root 3, are we supposed to locate root 2 at first? Yes. Okay, for locating root 3 at first we are supposed to locate root 2, then only we will be able to locate root 3 on the number line, because can you see root 2 is required over here. At first you locate root 2, then you will be able to locate root 3. Suppose this is the number line, you have located from here to here, you are saying this is the place of root 2. Okay, this is 1, this is root 2. Now only you made an arc over here. Now what you will do, again you will repeat the same process. Here you will drop a perpendicular of 1 unit and then you will join like this. Automatically your hypotenuse will be of root 3 unit. Getting it?
Yes,
Is
ma'am.
it clear
Yes,
to
ma'am.
all of you?
Yes, ma'am.
Okay, let me check what else was there. For root 5, you can understand. Root 2, root 3, root 5, these questions will be there in your exam. So root 5, again you think about it. Think about it. This hypotenuse, we want it to be root 5. So what can be taken as a base, what can be taken as a height? So are you able to, who will say what can be taken as a base and what can be taken as a height?
Yes, ma'am.
Who will say?
Ma'am, can you repeat the question again?
I said that now we are going to locate root 5 on number line. Irrational, it's irrational number, right?
Yes, ma'am.
How? How will we doing so?
And we can take the perpendicular as 1 and we can take the base as 2.
we will take the perpendicular and as a 1 and base as just 2. Let's check whether it is possible or not. Please everyone check it. The hypotenuse MO, will it be root 5 if you are taking the perpendicular as a 1 and the base as a 2?
Yes.
It's coming, right? So it's simple. For locating root 5, we don't have to locate root 2 and root 3. Directly we can locate root 5, because get marking 2 on the number line and marking 1 on the number line, maintaining the distance 2 and 1, it's simple, right? Right? So
Yes.
to locate root 3, at first we need to locate root 2. To locate root 2, we just have to focus on root 2 only. For root 3, at first we'll be locating root 2. For root 4, root 4 is a perfect square number, the result is just 2. For if any time in the exam, just to just to confuse you, it says that locate root 4 on number line. You should understand root 4. 4 is a perfect square number. 4 means just 2. Okay, square root of 4 is just 2. If root 5 you have to locate, all this you don't have to think about. Directly you can take one of the side as a 2, one of the side as a 1, and you can again make the just join the hypotenuse accurately will be root 5. Getting it?
Yes, ma'am.
Okay, this is construction part. If you will not sit with compass and pen and pencil and scale, then it will be just like that, yeah, you are getting it, or maybe you are not getting, you are only not clear. So you need to sit with pencil, scale, compass, protractor, whatever. Okay, everything, all the geometry box, and then you have to do it by yourself. Then only you will feel confident. Okay. Just a second. Next concept over here. Meanwhile, I'm giving the question. Do it, then let me check what can be done. If x is equals to 2 plus root 3, then x plus 1 by x value you have to find. Please do it, everyone. Answer is 1. Okay, we'll be checking it. Rest of the student, please let me know.
I'm getting 4.
I'm also getting 4.
Okay, we'll be checking.
Yeah, 4.
Okay, 4. Just a
Ma'am,
second.
I'm also getting 4.
Okay, you are also getting 4. Just a second. We'll be doing it. Yes, Tejas, what are you getting? Sara is getting 4. Everyone is getting 4. Tejas?
Yes, ma'am, I don't understand the question that much.
X value is given. Tejas, x plus 1 by x we have. Rationalization concept will help us over here. Tejas. Yes, Heather, what you said? You are not getting 4, right? That's what you are
Yes,
saying,
ma'am.
Heather? Okay, let's check it. X plus 1 by x, that means x is 2 plus root 3. And 1 by x will be 1 by x will be 1 by 2 plus root 3. And then are we supposed to add this 2? Yes, we are supposed to add this 2. But this looks like we can do the rationalization over here. Yes or no separately?
Yes, ma'am.
Okay, have we learned the concept of rationalization? If a plus b type of a structure is there in the denominator, then what we will do? We will try making a minus b. That means we will multiply 2 minus root 3 over here separately. Okay, separately. At first, we are working on 1 by x part. So that x is okay, x whatever we are having is okay. We will be adding 1 by x with that, but 1 by x looks like 1 by 2 plus root 3. So let's do rationalization over here. Let me tell you, while doing the rationalization, we are not changing anything. We are not doing any drastic change. We are just changing the representation. Okay. So 1 by, if suppose there is a question that do the rationalization of 1 by 2 plus root 3. How you will be doing? You will multiply 2 minus root 3 in the numerator and 2 minus root 3 in the denominator. Because while explaining the concept of rationalization, I have told you if a plus b structure is there, then there is only one way to remove the square root from the denominator, and that is by multiplying a minus b. But since we are doing the multiplication in the denominator, we are bound to multiply the same thing in the numerator also. So automatically in numerator it came 2 minus root. That is fine. It is allowed in numerator. Root and all everything is allowed in numerator. Just we are trying to remove it from the denominator. So in denominator we are having 2 square. Okay, like this. 2a square minus b square, which will be 2 minus root 3 over 4 minus only 3, which will be 2 minus root 3 over just 1. Now let's add x and 1 by x. This is the result of 1 by x. Okay, we have not done any drastic change. See, we have just changed the representation. If any time in mathematics you are having 1 by 3 and you are writing 2 by let's say 6, that means you are not changing anything. You are completely allowed to write 1 by 3 as a 2 by 6 because both are exactly same fraction. Yes or no?
Yes.
Okay.
Yes, ma'am.
So we are allowed to
Yes,
do
ma'am.
so in mathematics. 1 by 3 means what? 2 by 6 or maybe 10 by 30. Okay, not 10 by 30. It will be, yeah, 10 by 30, right? Yeah, we can write it 1 by 3 as a 10 by 30. Why not? Both are equivalent fraction. We can use instead of 1 by 3, even if we are writing 10 by 30. Are we doing any drastic change? No. Just a change is visible to our eyes, but our mind understand that there is no change, right? Similarly, here 1 by 2 plus root 3 means 2 minus root 3. Let's add it, x plus 1 by x. X is 2 plus root 3. 1 by x is 1 by 2 plus root 3. That just came out as a 2 minus root 3. If we will do the simplification, root 3 gone, and we are having only 4. Yes or no?
Yes, ma'am.
Ma'am, can we write it as 2 square also?
No. 2 plus 2 as a 2 square. Yeah, we can write 2 plus 2 as a 2 square. Why we are writing like that? Because 2 plus 2 means 2 times 2. Okay? 2 plus 2 means 2
Okay,
times 2.
ma'am.
If we'll be having 3 plus 3 plus 3 plus 3, that means 4 times 3. If we are having 3 plus 3 plus 3, just that, that means 3 times 3. And if someone is saying, can we write 3 square? Yeah, we can write. We can write. But the concept is, the multiplication concept is there. Okay, square every time, cube every time, it will not work. Just the number of time it is there, that is getting multiplied. Just a second. So now I am going to take this question. If we have to locate this type of point, maybe under root 3.5. We know how to locate root 2. We know how to locate root 3. We know how to locate root 5. We will be able to figure it out how to locate this root 7. Even if for now we don't know. For now we don't know how to locate root 7, but maybe we will be able to figure it out. We will be thinking like in the same direction that there we just have to maintain a right angle triangle where the base and height we have to take such a number so that root 7 we will be able to generate as a hypotenuse. Okay, so we will be able to think about that, right? If we will be taking the base as a maybe, what can be taken as a base? Is it root 6 and
Ma'am,
height as a
6.
1, right? Now, for that means, are we getting the idea that to locate root 7, we need to locate root 6 at first? Yeah. Then how we'll be locating, if we have to locate root 6, then how we'll be locating? So, such a triangle where the hypotenuse should be root 6. Root 6. That means, what can be the base, what can be the height? Can we take, what can be taken as a base and height? Who will say? Root 5 and 1? Or
Ma'am,
maybe
what, ma'am? Can you explain it again?
if you have to locate root 6, how you will be locating on number line?
Ma'am, 3, root 3.
Root 3 and the height is root 2 or what? Root 3 whole square is just 3.
Now, what is the perpendicular?
That's what the question is. That how to locate root 6. What can be taken as a base? What can be taken as a height?
Some root 5 and 1.
Yeah, what?
Some root 5 and 1.
5 and 1. Okay. Yes, root 5 and 1. Okay, so this is how we can locate root 6. You have to just think about it. However, these questions will not be there in your exam. Either it will be root 2 or it will be root 3 and maximum it will be root 6 and all will not be even there. Okay, if even if it
Okay,
will be
ma'am.
there, then you how you will be thinking that I am showing it to you. Are you able to figure out by yourself, yes or no? Are you able to think all by yourself? Now let's locate this 3.5. Who will say what to do over here? Everyone is having geometry box. I'm giving you 2 minutes.
Yes.
Please bring it.
Yes, ma'am.
Everyone is having. If anyone not having, please take 2 minutes and bring it. Okay? Take 2 minutes and bring it because we are going to do this construction over here. How to locate root 3.5. Yes, we can write. Okay. When we have to locate root 6, we can take it as a root 2 and root 3. That is completely allowed. Okay. But the main thing is you should know what is the length root 2 and you should know what is the length root 3. So for locating, do we have to locate first root 2 and root 3? Yes. If you are trying to use this approach, then yes.
Okay.
Okay. Let's continue with this root 3.5. Everyone is having the scale. Let's draw a line, a straight line that is, let's say, OA of 3.5 centimeter. Done.
Yes, ma'am.
Now let's extend this line by 1 centimeter. Let's extend from A to B. 1 centimeter. Extend. Done. Done.
Ma'am, should we take the length as 3.5 centimeter?
Wave 3.5. Whatever is reflect. Then we
Oh,
have increased the length by 1 centimeter.
oh, okay, ma'am.
Done so far.
Yes, ma'am.
Now we will divide this line OB in two equal parts. Okay, how? By, if you are having compass, then you can place the compass at the point O. Just measure more than half. Make an arc over here, make an arc over here. And then cut that arc from by keeping the needle at point O. This way you are dividing the line in two equal parts. Do it.
I'm done.
Everyone done?
Yes, ma'am.
Okay. If you are done, then now take this much length, or maybe this much length, because both are exactly same now. We have divided this line in two equal parts. Okay. Take any of the length in your compass. Press the needle of the compass at the point this. Okay, let me name it. You can call it M. Press the needle at the point M and make a semicircle like this. M is a center, BM or maybe OM is the radius of this semicircle.
I'm done.
Now we will be dropping a perpendicular at the point A. Okay, so either you can use the protractor to drop a perpendicular at A, and in your school if it's strictly there is an instruction that use compass only, then please use compass and make a perpendicular at the point A. How we'll be making a perpendicular at A? And now only I have shown by making an arc like this, like this, like this, like this, like this, and then join. Okay? Please make the perpendicular.
I'm done.
Everyone done? Please let me know one by one. So far, if you are done or not. Anam, Arhan, Ifra, Heather, Saad, Irshad,
Yes, ma'am.
Aisha, Sazia,
Yes.
Tejan,
Yes, ma'am.
Samu.
Clear, ma'am.
Are you done so far?
Yes, ma'am. It's
Yes, ma'am.
done.
Okay. Now we'll be able to let's mark it a point. Let's mark it O M A B. Let's take anything. Okay, P, point P over here. Now you will find that this AP is on let's check this. The line. The checking part you can also focus if you want to. First we draw X. Then we did 1 centimeter. It became x plus 1. Then we divided this line in two equal parts. Okay. This was, let's say, B. So AB was x. Then BD is 1 centimeter. Now the complete line AD is x plus 1. Now we are dividing it in two equal parts. That means AO and BO both are half of this x plus 1 by 2. Okay. Now what we are doing, keeping the needle over here, we are making a semicircle like this, and we are dropping the perpendicular over here. This much is the radius. Okay, this if this is point P, then OP is radius of this semicircle, and radius already we have figured it out. That radius we have maintained for this semicircle, the radius we have maintained as a OD or A. This was the radius, x plus 1 by 2. So radius we already know, this is x plus 1 by 2. Okay. What about this much part BO? So we know that from O to B, if you are not getting, please don't get confused. Please don't get confused. I don't explain this concept to a student because I have found that most of the time student ended up getting confused. Okay, so from O to B, this is x plus 1 by 2, and from B to D is 1. Yeah, B, BP, this much is root 3.5. Okay, here in our figure, AP is root 3.5. Any confusion? Okay, just focus on the construction part. Whatever decimal number is reflecting over here, that much length, then 1 centimeter. Take a pause. Now you have to divide this complete line into equal by dropping the perpendicular like this. You are done. Now you have to press the needle at this middle point which you have found just now. Make a semicircle by taking the radius as a MB or O. Okay. Now make a semicircle. After making a semicircle,